All right, so I have about 7 slides to show you just to kind of provide a little bit of an introduction and some clarification and some of these high technical things that I'd like to make a little bit clearer. So here's what we're going to be doing here today. Obviously, the introduction, right? That's what I'm doing now. The second part, I'm going to show you how to protect a website against different network attacks, denial of service, using our proxy mode. I'm going to run you through the configuration and the policy, which for those of you who are in the first webinar, have seen the first webinar, will be a little bit of covering that ground again. Then the reason we have Fredrik Hugge here is we're going to be launching a volumetric attack. I think when we tested it, we got quite a few gigs of traffic. So we're going to be launching live real traffic against our website over the internet. Then we're going to kind of take a look at the way data flows through Riverview. And that, unfortunately, is where we come back into PowerPoint for a few minutes. The next demonstration, the next part, is I'm going to be launching an HTTP attack using a tool called Locust and a cluster in Google's cloud service. Then we're going to be pivoting a little bit and looking at our threat inspection functionality. I'm going to run a couple of different threat inspection type attacks, the Apache Struts vulnerability, uploading some malicious files, and then something I like to call script kiddie fun, where we just kind of throw everything we can and see what happens. Then we're going to talk a little bit about logging and open it up for questions and answers. For those of you who don't know who Baffin Bay is, and I hope that you would at this point, you know, we are a security startup and we're based in Stockholm, Sweden. We've been out of stealth mode since April of this year. And the cloud, what we deliver is a cloud-based security platform as a service. And we're going to be looking at three major things that we have here today. First is the denial of service mitigation, and the second is the threat detection. The web application protection module will we'll cover that in a third webinar, most likely in January, and probably tie that with some advanced logging capabilities as well that we have. And here's what we come to work every day to do. We want to build the best cloud-based security platform to stop both network and application security attacks. That's our stated mission. That's what we try to do. Now, I hope that nobody is tired of PowerPoint already. And we can start jumping into Riverview. So we're going to start out here by showing you how to configure traffic. You know what? Scratch that. What's the core part of any security product is the policy that you create, right? What's the bad stuff to block? So we're going to go into threat policies. And I've created one that I call Acme. That's our fictional customer here, Acme Banking. And you can see that they have a production threat policy. If we go ahead and take a look at that, we can see the name, description, yes. And now we start configuring what this policy is supposed to do. The first part here is threat intelligence, okay? Threat intelligence is a sum total of all of the network, threat feeds that we pull in and the data that we generate from our honeypots and from all our internal systems to be able to take known threats and place them into categories. And you, when you configure this, can say, okay, well, if there's hosts that we know have been involved in application denial of service, yeah, let's drop those. Same with botnets. We divide it out into a fairly granular level here. So as you see in my policy here, I'm dropping almost everything, but I'm logging scanners, proxies, and cloud provider networks. a large part of that is because I think these we want to have alerts for and be aware of, but they're not necessarily going to be a threat in this instance. The second part of our policy is where we can add in custom threat feeds. This is a pretty unique feature for us where if you've got a Splunk server that generates some interesting data or whatever other SIM that you have, or you're a member of an industry working group, or you gather threat intel, you buy it from a third party, you can actually take that information and instead of putting it on your firewall or your IPS on-prem, you can shift that blocking all the way out to our threat prevention centers in the cloud. And you can drop, you can log, but we also have recently added a new functionality to the threat feed where you can set the default action in the feed itself. So if you, for example, put a W next to it, you could whitelist a host, so not block that. You can block, you can alert, and configure that based on your feed itself, rather than having to have all one thing, all the other. The last part here, and we'll be looking at this in the kind of third demo I'm giving here today, is threat inspection. And threat inspection gives us essentially two options, which is let's go ahead and block known threats using IPS-like functionality, file hashing, known bad executables, that kind of stuff. And also the second checkbox, which allows us to identify unknown threat. Basically, we don't know what it is. Let's go ahead and put it up in a sandbox in the cloud and get a conviction on that. And if it's bad, let's go ahead and block it in the future. Once we've created our policy, next part is to create some way to use that. And you see, I have this one here, bbndemo.website. And if we go ahead and edit this, you see it's pretty straightforward, right? This is actually a web server that I'm hosting in Google Cloud. Here is our scrubbing center IP. That is when you put it into, when you set up this, we give you some IP addresses. I've chosen .23 out of this range here. Here's the port I expect traffic on, and here's the back end. Now, if I go to Google Cloud, let me walk you through the whole process here. So this is my server sitting in Google Cloud Platform. You see, it's not a very beefy one CPU and just under 2 gigs of memory. It's got a IP address here ending in 232, and it doesn't really see a whole lot of traffic on a given day. Let's go ahead and bump it out. You see a little bit of spikes here and there where we're running tests, but essentially nobody goes to that. So when we look here, there's that IP address. Now, in order for me to get that traffic that's destined to that web server into Riverview, what I've done is pointed through my domain registrar, and please don't make fun of me for my domain registrar. We are a startup, and 88 cents to register a demo domain seemed pretty good for our budget. So you'll notice that the 185, 195, 93, 23 is where I've set my A record in my domain registrar for bbn-demo.website. And that's the one that I'm being used here. So essentially, when traffic comes in, I want to go to this web server right here. I hit the domain registrar, get the A record, get pointed to Riverview. Riverview then takes the traffic, proxies it, applies its policy, and the traffic is then redirected here to my instance sitting in Google Cloud. I wanted to show the entire process to make it clear and also show that we're not doing anything kind of secret SE magic tricks in the background. For advanced proxy settings, I've set my max connections to 50,000, just so I can show you that we have a built-in slow connection policy. This does protection against things like slow LoRa's, slow HTTP read, and those kind of slow attacks. And I also have inserting XFF header on my HTTP request and turning on logging. For my policy, here's the policy that I created previously. So there it is. And for my denial of service policies, I'm actually going to let the system decide. And this will make sense when I show you how data flows through the system in a few minutes. But we do provide you with the ability to go in and tune those manually if you want. What we recommend is that you allow the machine learning that we use to go ahead and adjust all those settings automatically so you don't inadvertently cut something off, right? That statistical analysis really will help you to protect against that. So now that we've set up our traffic and everything's going, you see I can go and access the website here. We're gonna go ahead and start doing some attacks here. So at this point, Hugge, you can unmute yourself for a second, and I'm gonna kind of introduce a little bit about what you're going to be doing. Fredrik is our network engineer here. I don't know, are you head of engineering or chief network engineer? He's a guy who, whoa, you back?
Yeah, I'm also sitting in the data center currently, so I'm not sure how noisy it will be, but
it's okay. It adds a certain je ne sais quoi to your comments, right? It makes it seem like we're working hard. So what Hugge is going to be doing is launching a volumetric attack against our web server. Hugge, could you explain how you're going to be generating this traffic? Maybe. Here, let me unmute you.
yeah, there we go. Yeah, it's a bit flaky in here.
It's okay.
Yeah, so I kind of missed like the last 8 seconds or what you were saying.
I want you to explain to everybody in the call how you're going to be generating traffic.
Right. So we will use 2 different methods. First, we'll use like a UDP non-spoofed attack, which I will generate from a tool, an actual traffic generator. And I will also use a regular PC to simulate, like a regular guy having a big internet connection to powerful computer trying to generate an attack, because that kind of things happen. So there will be 2 attacks in one, which is a bit different to mitigate, of course, because the one attack that I will generate from a computer will be a spoofed attack, much very alike those attacks you read about in the newspapers.
Okay. Now, are you doing any tricks with average packet size using like jumbo frames or anything like that? Or are you just using kind of a standard IMIX?
I will use not a standard IMIX. I would say I will use 64K packets for the source, for the spoof hosts, to try to drain, with in terms of PPS, not in terms of bandwidth, but actually drain capacity with PPS. So hopefully I could be able to generate, I don't know, like maybe 2 million packets per second or something like that from a PC.
Okay. So what kind of traffic amount do you think you're going to be able to pull out for us today?
I hope maybe like 8-9 gig. Since we're doing this over the internet, I don't want to break the internet. So we need to be a bit wary here that it's big enough to be cool, but small enough to not actually break anything along the way. I'm not as worried about Baffin Bay per se, but there's a lot of people on the way to Baffin Bay that could potentially break if we make this too big.
Okay, and that kind of brings up the last question. I just want to point out that we have asked the people along our path if it's okay that we do this demo today, correct?
Yes.
We have permission to do this. We're not breaking the internet without permission.
Yes, correct.
All right, cool. If you can go ahead and then start beating me up, that would be great.
Yeah, could I steal the screen maybe? Right, so this is, I should be seeing one of my terminals right now, I believe.
Yep.
So this is just a very, very simple, which is also kind of, We don't need to make it more advanced than this because this is easy enough that the kids can actually do it. So I will just generate a whole few of these ones, just to make sure that the traffic will actually be started. I have quite a lot of CPUs and memory in this box, so that's why I want to generate a lot of HPings. And we can verify this. That yeah, we're running pretty hard on the CPUs here, which you should be able to see, and also that we actually see traffic leaving the box here. So this is generating about 3 gigs. Now I'll also activate, which you will not be able to see because it's actually a physical box which I have in my hand, which is also why I'm in a data center, to generate a non-spoofed attack with UDP. That should be able to, enable the last amount of traffic for us here. So
Okay.
so now I'm logged into one of our switches, one of our routers here in Stockholm. And as you can see, I have just before the demo, I had a regular port here, just essentially idling here for the demo website. And if everything goes correctly now, so this is an 80 gig trunk towards one of the proxies. So now we're seeing about 6 gigs coming up pretty slowly here, 6.5. We're doing what's that? That's about. And just to prove here that we're actually doing this for real. This is not a joke. So
There we go. So you got 7.5 gigs coming there, plus the
yeah,
coming.
right, and also with like 10% framing overhead here, since I'm reiterating very small packets here from the PC. This is, as you can see, it's Windows size 64, and right. I'm aiming at towards 480. So this will be a lot of Ethernet overhead. So this is actually almost a full 10 gig with 11% framing overhead on top of 8 gigs of real traffic here. All right. So I guess that makes it time for me to hand over to you back again, right? So
Please do.
Yes, I'll stop sharing here. I'll also mute myself so you don't have to hear.
That'd be great. Because I think more importantly here, let's make sure that our website is still up. Still pretty snappy. Let's go ahead and use the alternate there to make sure it comes up. So what do we see when we come into Riverview? All right, now you see when I go ahead and refresh, we see there's a denial of service attack happening here. Multiple sources, TCP push flood. Let's go ahead and pop into there and take a little peek. Well, we see that we got 66 pages of different IP addresses coming here. And the traffic in terms of packets per second over time. I think here's a small issue here, but we see 6.5 million packets per second coming into the system. So we've got, in this example, we've got somewhere around 8 gigs of traffic, 3 of those which are hitting in one way, and 7.5 or so that are, I did bad math there. Anyway, we've got a lot of traffic coming in, around about 8, that is up far and above what I'd say the average denial of service that we see on the platform is. And it's ongoing now, so we can actually go through, and this will be updated as the go on, right? Because there's no end time registered. Maybe we want to create a new incident, ongoing denial of service attack, right? And see what's going on. But as you can see through here, the website is up, even though it's being hit with a fairly large amount of traffic coming from multiple sources in different protocols as well. Make sure that everything's coming up and fine. Check it one more time. So just a massive amount of traffic that Hugge is sending towards us right now, and not a problem at all. And that kind of takes me to the next part here that I want to talk about, which is what's actually happening to the data as it hits the Riverview system. So Hugge, you can keep your traffic going if you want, or stop it if you want to get out of the data center and have a cup of coffee. That's up to you.
Yeah, yeah. I think I'll stop it and jump out here.
Okay, thank you very much, Hugge.
Thank you, no problem.
All right, so the next part here that I want to show you is what happens to data when it comes through into Riverview. So it's important to point out here that this does not show the sum total of every module, every traffic inspection point that we've built into the system. This really just has the ones that are relevant to the demos that we're having today. For example, web application protection is not in here. But what happens is when Hugge fires up his bots here and launches his attack, the first thing that it encounters is that threat intelligence that we configured in the policy there, right? And that's our first line of defense. Essentially, that provides us IP reputation to protect against known bad threats, right? We take in approximately somewhere around 140 different data feeds, both that we generate internally and also ones that we curate from third parties. And the benefit of this, of course, is that it's very fast. We do this in hardware. So when you choose to block those, choose those to block in your policy, that is written in the hardware. We can block that fast, easy, don't even need to think about it, no sweat. The next part here, which is where Hugge was testing us, was in the network denial of service module. The network denial of service module is kind of hard to put into words without giving you guys kind of a word salad slide, and I wanted to skip that. So I built this graph to kind of show. So if we assume that that blue squiggly line is traffic through traffic to my website over a given period of time, then we also have two different lines that I've written. The green one, which we'll call a tracking threshold, and the red one, which we'll call a blocking threshold. What happens is you'll notice that there are these two different points here. And when traffic goes above what we have seen, right, with our statistical analysis, and realistically, we need about 3 hours to get a good statistical analysis. However, if you were to call us in the middle of an attack, there are ways where we can mitigate that without having to do this calculation. But essentially, with 3 hours of time, we can then start noticing, wait a minute, this first bump here with the light blue arrow, that goes over our tracking threshold, and that gets the system's attention. We start doing additional math, additional calculation on that traffic. And in the case of this graph, that was just kind of a test, right? Testing the bots to make sure everything's working. And then comes the big flood here. And that flood pushes it past what we call the blocking threshold. And because it's so far above what we normally see, and we do that statistical analysis, the system has learned that everything above that blocking threshold is no good for you and safe to go ahead and shave off. Now, what I will say is when you're dealing with statistical analysis, right, it's possible to have false positives and that kind of stuff. What we've seen so far is that no customers, no issues with any sort of this, with the blocking threshold being put in and having false positives. So that's a really good sign. And in this graph, it was kind of hard to show, but the blocking threshold and the tracking threshold are mathematically related as well. So as your traffic grows and changes over time, they move, they're kind of pegged to each other. So they move in accordance with each other. So that's generally how the network denial of service part works. Traffic that passes through those two then comes to the BOK Defense module. We'll see this in a little bit. where we have about 1,000 signatures for detecting known bots. So some examples of that are those kind of well-known bots that are out there. You can buy them on the darknet, or you can build your own bot that is doing bot-like behavior. I think the one we see in the events later is a curl bot. So just a bot that's doing certain things. When we see things that match these signatures, we can go ahead and safely remove that traffic. The next part here is the HTTP module. And what the HTTP module does, it's very similar, mathematically speaking, to the way the network denial of service functionality works. Except for instead of tracking traffic over time, it tracks transactions per second. So when we have that tracking threshold and that blocking threshold, because we're dealing with HTTP transactions and we're protecting websites, we obviously don't want to just say no and start blocking things willy-nilly. It's a little more muddy than that. What we do is we can then send a JavaScript challenge. Are you using a web browser and able to actually take and complete this calculation? Or if that fails, we'll send a CAPTCHA and say, please prove that you're not a robot. If you fail both of those, then we feel safe to drop the session. It's important to note also that when we find things that are bad in any of these kind of three modules here, they all kind of work together with threat intelligence. So we can, for example, in network denial of service, when we find something that an IP address that is attacking you, we can actually pass that up to the threat intelligence module and block it earlier in the stream, which allows us to do things like you saw with Hugge's attack previously. Those first four modules are all kind of the base functionality of the product. We also have the threat inspection module, which is the last part of the demos I'm going to be giving you here today, where we can do detection and mitigation of exploits. So not just your denial of service, not just the kind of bot and the typical stuff that we've been talking about, but actually providing an IPS-like functionality out there in our threat prevention centers. So in the demos, I'll show you what happens when we launch an Apache 2 struts vulnerability. I will show you what happens when we try to upload a known bad file, or what happens when we try to upload some sort of unknown file and let the sandbox go ahead and do its thing. And that's all in the threat inspection module. So that's the flow of data from beginning to end. And we see it very much like a funnel, right? Taking in the biggest source and being able to shave off and trim down that data, because when you're working with gigs of data a second, it's very easy to be overwhelmed by just the sheer amount of data. My background is in IPS, and for the longest time, the wisdom was don't put your IPS on the outside of the firewall unless you want to know the internet is a big bad place. I think we all know that. But because we have the ability with the advent of improvements in SIM technology and kind of the big data push of a few years ago, we can actually use all of this data and send it through logging or through an API into a SIM tool and provide that funnel down to gather all of the information way out far away from your assets, so you can then leverage it to protect your assets in-house by doing some stuff with your SIM tools. As I said, there is a module here, the web application protection. We'll sort of touch on that briefly, but that webinar will be in January. So if you're following us on our LinkedIn page, you'll certainly see it there. The last part, and this should be the last slide, I promise, for the day, is that architecture that I just showed you, that data flow, happens across all of our data centers. So what this map actually shows is data centers and peering points, as well as planned data centers in red. Those should be done in the beginning of next year. So if you have a globally distributed attack, those will hit whatever the closest threat prevention center is. And that data flow will go through in each data center. The sum of all the statistics and the information there will then be combined and collated across all threat prevention centers. So we're actually blocking these things closer to the source than, you know, having to shunt all the traffic to the closest data center to you and that kind of stuff. All right, so the next part here that I want to show you is this Google Cloud attack that I've built up. So just again, doing this with permission, I went to that Google Cloud Summit in Stockholm a little while ago and asked Google how I could use G-Cloud to launch a DDoS attack on myself. They preferred I called it load testing. So they provided me with this article, which is a reasonable article. It's a little old though, which shows you how to set up Locust to create a swarm to attack your web servers. And there's a whole how-to on how to do it with pretty old commands. The result of all of that is that I've ended up building this script here, which sort of goes through and does everything for me. If I go to my command line here, we should see that it is sitting here. There it is. So here's me panicking before this webinar started, getting everything up and running. So because the how-to is a little out of date, I have plans to create a blog post to show you guys if you want to be able to test your own systems, because denial of service, especially denial of service protection, is really hard to test, right? You don't want to go out to some shady booter service and test your corporate infrastructure. So I think with this, you can actually get a good idea on how you can test your traffic over the internet legally. And as well, when you sign up with the Google Cloud stuff, they actually give you $300 free credit. And I think I've used about $100 of that running this just about every day. So it's pretty cheap as well. When you set up here and we look at my VM instances, what I've set up is a 7 node cluster here running in their Europe West 2. And it gives me this Locust ability to swarm with Locust. You'll see the target here is bbndemo.website. So let's go ahead and just put in 1.5 million users, right? Yeah. And it can't hatch this fast, but let's go ahead and just start that. And you'll see it starts going out and making requests, right? And this all corresponds to things that I have up on the Acme Bank website. Let's just go ahead and test to make sure my website is up and running, right? So it's going ahead and it's requesting the contact us, a couple of different pages I have. I'll show you guys these later. And then trying to download a 10 meg, just a large file to try to put some additional load on it. This demo used to be way more impressive because the request would start and then we would start killing it off. However, we made some improvements to the system, which is good, but it looks a little not as sexy because none of the requests go through. I'm going to go ahead and leave this running and we'll go over to Riverview again and refresh our events and take a peek and see what we've got going on here. So now we've got a whole bunch of stuff happening. Let's see, a DDoS attack here. That's Hugge's DDoS attack. Let's go ahead and see we've got bot requests, right? So essentially what happens is, since we've put in the bot module, soon as I run this, we actually see that this is bot-like traffic, and you see all the different requests that are happening, and we drop it immediately due to being able to see that, okay, it's a Python request, it's running here, here's my sources, everything's fine, everything's blocked. I also want to show what it looks like. Part of the reason that it's doing that also is because this website doesn't have a tremendous amount of traffic. So when we look at this from our main Baffin Bay networks, I was also attacking our main website. So if I look for application attacks, refresh this, let's see. Find the event that I want to find. Here we go. So here's another one where it shows up as a TCP push flood instead. And you see we've got our hosts coming up here running their attack. And instead of blocking it based on bot defense, I've changed the locus settings. And hopefully when I get to posting this on the blog, you guys will be able to understand and see how this is done. But essentially what happened is I sent a bunch of packets doing that HTTP GET. And within a second or two, we started shaving off that traffic and killing the sessions. Gonna go ahead and switch back here. Probably good idea, good to go ahead and stop this attack here. There we go. Go ahead and close Locust and just make sure the website is up and running. So when I've been looking on how to test this, I found that this test was easy enough to set up. It's scriptable and it's cheap. So it's a very good way to test. I think over the time I've been running this, we can generate about 250 gigs of traffic a day doing this, and that's running it 4 or 5 times a day. The next part here is to talk about the threat protection module. And that moves us out of the realm of just your standard network traffic attacks, right? I've got my cluster set up here, but I can also go over to this tab here where I've actually downloaded something really easy called structpwn.py. If I scroll back here, here it is right there on GitHub. You can download it, test it yourself to test struts. So let's go ahead and this is a pretty famous vulnerability these days. I'm going to go ahead and just run this attack a few times. And now that we've got a couple of attempts to compromise my website, when I go back to Riverview and I refresh this, let's go ahead and change it. Oh, nope, don't need to. Cool. We've got an alarm bundle in here where we can see the Apache 2 REST plugin, or the REST plugin Extreme RCE, right? We can go and Google that and get more information about this, but this is where I'm talking about the kind of IPS-like functionality, where we can see that in this case, we blocked this coming through. We see the payload, okay, what happened, where was the vulnerability attempted, so I can then take this and do some incident analysis. Maybe I want to add it to a new incident. There's also another event that gets bundled together with this. Like I said, we try to funnel things as much as possible. And you'll see that in this case, it's identifying struts.pwn, but the user agent. This one's allowed because a user agent isn't necessarily a bad thing, right? I change my user agent every day. and we get the information a little bit about this just to add context and enrich the event some. So there's just a simple, easy to reproduce attack, trying to do a live exploit against here. A couple of more things I want to show, and then I've got about 5 minutes more of things to show you guys, and we'll open it up for questions. I also have back here at Acme Banking Solutions. If I go ahead and click here, we get to an ability to upload some files. Trying to upload. If we go over to Riverview, get our new data here, and you see immediately blacklisted file blocked, right? Easy peasy, not a problem. Let's go ahead and go back and choose a different file this time. And this one here is just an ICAR file that I've uploaded, changed the name a little bit because I'm a sneaky hacker. And let's go ahead and upload that one there. And while I'm here, I'm going to go ahead and upload, I'm going to go ahead and upload this PHP file, because this is supposed to be to upload images. However, we don't do any file checking. So let's go ahead and upload our PHP and try to get a shell on here. So while that's uploading, let's go ahead and look at our events yet again. And oh, it already came through. Cool. First thing we've done is we see that the ICAR file, we actually popped that up in a sandbox. And then the sandbox said, wait a minute, that's ICAR. Here's your MD5 and SHA-256 hashes. Go ahead and find that. For stuff that there's Yara signatures, we can actually display that, but this is ICAR and not needed, right? Where it's coming from, my existing IP, where it's going to, here's the file. We can go ahead and protect my website against this file being uploaded. The last one here is the PHP shell that I tried to upload, where we see that there's actually PHP tags in this HTTP post, and it's been blocked, right? How many packets, how many bytes, and we see the text here of what I've been trying to actually upload, right? So in this part of the demo, what I hopefully have shown you is, that we can protect against those kind of known exploits, right? Michael Carey, our director of threat intel, this is what he does every day, comes in and reads vulnerability disclosures and goes and tweaks and tunes and maintains all of the different protection and sets the defaults for our customer base. Then we've gone ahead and looked at both a known and an unknown file. Now, the last thing that I want to do is have a little bit of a script kiddie fun. So I've gone ahead and set up my Kali Linux here. And I'm going to go ahead and log in. And here's my website here, right? So let's go ahead and find attacks. Cool. And we'll go ahead and do, for those of you who aren't elite script kiddies, Armitage is essentially a front end for Metasploit that makes things easy. And so what I'm going to do is what's called a Hail Mary, which is I just want to run every possible attack I can against this website. So it's going to launch a flood of exploits. Sounds good to me. Let's go ahead and let it do its thing. And that's going to run for a little while. And when we get back into Riverview, we'll see that there are a few events that get generated. All right. While that's running, let's go ahead and get back to Riverview. Escape out of here. Still generating events, so we should see. Let's go ahead and change this to last hour. Keep things simple. All right, there it goes. Now it's starting to bundle in things. So we see a bunch of different PHP tags and HTTP posts, right? Blocked, bunch of different events. Actually, if we refresh again, I think this generates over 100 events in this one single alarm bundle, right? So as they're coming in, it will continue going through, finding all these super cool script kiddie attacks and blocking them where appropriate. We'll go ahead and just take a look at our alarm bundle one last time before we go ahead and close it. Ooh, 157 attacks. We also have the option here to send these events into a logging system. So this is a little beyond the scope of what I prepared for today. But in the next webinar, what I want to show is how we can take all these events, all this denial of service attack, the DDoS attack, the bot attacks, the threat inspection events, and then send those using log forwarding or the API into a SIM tool. So see, we have both the ability to forward all events or forward events on demand. So if you don't want to overrun or clog up your SIM tool, you can actually just send in some events. We are currently working on building a Splunk app. And so in the next webinar, I hope to actually show the work that we've done there. So you can see how you can not only block things here, but visualize those events in your Splunk server using the Splunk app, and take action and shore up your defenses across your entire organization. For those of you who are interested in the work that we're doing and want to hear, for example, when I get the Locust blog post written, which is currently stuck in trying to figure out what's wrong with Google's implementation of firewall rules, go ahead and follow us on LinkedIn, and we will be posting it there. For those of you who want to share what we've talked about here today with people who weren't able to come, maybe those who are double and triple booked already, I also created a bit link to our YouTube page. So hopefully later today, I will be able to take this recording and get it uploaded into YouTube. And you can go ahead and share that with your colleagues, your friends, your wives, your mom, whoever might be interested. Finally, if you have any questions, you want to see anything in particular a little bit closer, feel free to reach out to me. My email is james@Baffin Bay Networks, or any member of the Baffin Bay Networks team, and we'll be happy to help you. Okay, and with that, I want to thank everybody again for taking the time. Have a great day, and please feel free to reach out to us.